Hi everybody, so my name is Haviv. I work for Databricks. We recently opened our new Israeli branch in Israel. Right now we're just 2 people, but we're expanding. And today we'll talk about simplifying your production machine learning with MLflow. Apologies, I thought that that it's going to be in Hebrew, so I might stutter a little bit. And another apology, the email here was a last-minute edition, so it has a typo. Okay. Just a few words about Databricks. How many of you know Databricks? Raise your hand. Okay. How many of you use Spark? Okay, so basically, Databricks is more than Spark. We aim to solve the problem that exists in many organizations where you have groups of, like the whole ML flow, all of the flow towards productionizing ML involves a lot of people in the organization, data engineers and data scientists and DevOps and application developers and so on. And our aim and goal is basically breaking those silos and making everybody work together using what we call the Unified Data Analytics Platform. Those of you who know Spark, so you probably know that our founders are the original creators of Spark, also Delta and MLflow, which we'll discuss right now. So what Databricks has brought to the world recently, MLflow, which we will discuss now, Delta Lake, which in 2 words allows you to treat your data lake as a database. And maybe the most interesting for the people here, except for MLflow, of course, is Koalas, which exposes a Pandas API over Spark. All of these projects are open source. You don't have to pay Databricks to use them. You can install them in your own data center or environment and start using them. Okay, so let's dive into what we all came from. Let's understand how can we help productionizing your machine learning workloads using MLflow. Today we know that ML development is way harder than traditional software development. And I think we all can agree that traditional software development is not easy, okay? And in what way is it harder, okay? So if, for example, in traditional software, the developer had to develop a certain functionality, and it's very obvious and very clear what needs to be done. The goal in machine learning is to optimize for a specific metric, okay? How is this different? It means that we constantly need to experiment and improve our algorithm. We constantly need to feed it with new data, recent data. We need to change parameters and so on. It's way more difficult and cumbersome than just writing some code. No disrespect. Okay. The second differentiator is the fact that quality, when using on traditional software development, it depends only on code, right? On the code and the coder. In machine learning, the quality of your products depends on input data, the training method, parameters, and so on. Which kind of libraries did you use, and so on. And again, another key difference is the fact that when we talk about traditional software development, typically we have one stack that is used throughout the organization, or even if we have a big organization, at least at our subsidiary or our group, we'll be using one software stack, which a lot of developers across the group know. But when we talk about machine learning, in the same group, in the same team, we can have different personas working with different libraries, different languages. One wants to use Keras, one wants to use TensorFlow, one wants to use Java, one wants to use Python. And we need to be able to support all of these because the technology also drives the results, in our case. And this was only the development stage, right? In production, getting things to production is even harder, okay? Why is that? First and foremost, once you develop or once you train a machine learning algorithm, it's not static. It won't stay relevant in another month, 6 months, or even tomorrow. You need to constantly keep training it, and to keep training it, you need to feed it data, okay? And there's a whole cycle here, which seems like it's unidirectional, right? It runs from the raw data to the data engineer to the data scientist and deployment, but that's not always the case. Usually what happens is that the data engineers receive the data, they do their transformations, and then pass it on to the machine learning engineer. The machine learning engineers usually look at the data. Sometimes they'll use it, sometimes they'll get back to the data engineer and ask for modifications, and there's a back and forth cycle going on within this cycle. And then let's say that finally the data engineer is happy, and they produced us with a machine learning model. Now we need to convey to the DevOps people or to the application developers how to deploy and use our algorithms. And again, different technologies, different ways of using and invoking them, and it's very cumbersome and very complicated. So to answer those challenges, basically, first of all, I'm sure all of you face those challenges, okay? And just as you face those challenges, so are the giants such as Facebook, Uber, and Google, okay? And they also develop their own platforms, okay? And those platforms basically help you standardize the whole process. How do I prep the data? How do I push it to the data scientist? How do I train? And then how do I deploy? Okay, so why not use these if they already exist? First of all, they are limited or optimized to specific use cases of these companies using specific algorithms and specific frameworks, okay? So they might be very good or very cool, but they don't necessarily fit your needs, okay? And another issue is that they are tied to one company's infrastructure, okay? So you guys are not Facebook. I'm not talking about size or business cases. I'm talking about the infrastructure. You want to deploy on SageMaker. You want to deploy using Spark or whatever. Facebook has another way of doing things, okay? So we banged our heads and we thought, how can we provide a standard for machine learning, productionizing machine learning in an open manner. Open both in terms of open sourcing it, and both in using it within the organization and plugging into it. So in 2018, we unveiled MLflow. We open sourced it, and MLflow is basically comprised of 4 modules, which we will dive deep into right now. The first one is tracking. Okay, tracking basically helps us record and monitor our experiments, understand why one experiment is better than another, which hyperparameters were used, which version of the ML library we're using, and so on. The second one is the packaging. It basically helps us ship our trained model, or the project itself, not necessarily trained already, but ship our model or our environment to maybe another laptop of my coworker, or maybe to a cloud environment, to a notebook, and so on. And MLflow models, and I'm sorry about the indentation, yeah. MLflow models, which allows me to basically define how to execute my model. And this way I can deploy it to several environments without knowing the specifics or the details of how to run, I don't know, Keras, how to run prediction with Keras, or how to run prediction with PyTorch. I don't even need to know that they are being used for that matter, okay? And last and not least, but recently released, is the MLflow model registry, which helps us track our models and understand, and basically open, let's think about it as an in-company marketplace for models with a clear understanding of what is the differences, how each model was trained, and so on. In terms of market adoption, today we're looking at 800,000 monthly downloads of MLflow. We have over 140 contributors, and coming from 40 different organizations across the board. So this is not a Databricks specific project. This is an Apache project. This is open source. Yes, you can pay Databricks for it, but you don't have to. And just a little bit more metrics about popularity. So you can see that MLflow gained in 1 year more contributors than what PyTorch gained in 4 years. So let's discuss the first part of MLflow, the first module, which is experiment tracking. This time is until the questions? Okay, until the questions, okay, sorry. Okay, so let's discuss experiment tracking. Basically what we want is something that is decoupled from our environment, so I can run whatever, I can use whatever tool I want to develop, if it's a notebook, if it's local apps, bash scripts, IDs, or whatever, or cloud jobs. And I want to report all of the processes, all of the findings during those processes to somewhere. That somewhere would be the tracking server, the MLflow tracking server, which later then exposes both a UI and the REST API. The key things that we measure or track using the tracking servers are the parameters we used for the training, which metrics, so how accurate was the model using these parameters, which artifacts we use, so you can provide artifacts which were the result of the run, let's say a plot, or you can provide artifacts that were used during the training, like, I don't know, a CSV which maps IPs to locations. And what version of the code we ran, which is something very important, which people don't pay attention enough to, because I have a model that's running for a year now, and something deteriorated. I want to know at what version of the code the model started predicting badly, and usually we don't track. Usually when you do it at home, you don't track it. So how does experiment tracking looks like without MLflow? Basically, the naive solution would be just printing out to standard output, right? In the best case, you have an Elasticsearch cluster, and you pick up all those logs and aggregate them into Elasticsearch, and you work with Kibana or something. It's very cool, but you find that it's very easy to get lost. And I'm not talking about just printing to std out, because this doesn't scale at all. And what happens if I tune other parameters which I forgot to include in my print statement, right? Or what happens if I update my machine learning library, okay? I will see unexplained changes in the accuracy, but I won't have any explanation for that. And of course, what happens if I used another version of my code and so on? There are more questions like that. How does experiment tracking look with MLflow? So basically, this is how it looks. You also log them. You also need to log your parameters. You can log artifacts such as the model itself, again, plots, anything you want. And then you can just invoke the MLflow UI. And when you do, you get this screen which shows you all of the, I hope you can see, but if not, there's a larger version of it in the next slide. You can see that your experiments and what was used during the experiment. So in this short video, you can see that I'm actually drilling down into a specific model run, training that is. Okay, I can see what parameters were used. First of all, I sort them by the accuracy, because I want the most accurate model. And then I can inspect and see why was it so accurate and so on. I can add comments to it. So that's the first run. Another feature that is useful is actually comparing runs. So I have two runs, okay, with similar accuracy or not, or very far distant accuracy from each other. I want to understand why. I can compare them and can look at their parameters in one shot, one screen, and understand what was the difference, and maybe it will lead me to optimizing my algorithms better. The second issue is basically reproducing your project. So I'm sure all of you, or most of you, sat and started installing CUDA and stuff like that, or I don't know, PyPy, and there are so many issues with dependencies until you solve everything, and it's a pain. It's a pain. So one of the challenges is, okay, now you have, let's say you have a new team member. You want him to work, or him or her, to work on that specific algorithm that you're working, right? Are you going to make them go through the hell and pain that you went through while installing your environment? You can just package it. You can just package your work environment using YAMLs, okay? And you can ship your environment as is, okay? Very similar. It's a bit similar to Docker, but it's not Docker, right? It's just for data science. So you can ship your whole project to another computer, to the cloud, wherever you want, easily and safely without the pains of installations and dependencies. And this is also how you run your project. It's very easy. Once you have the YAML in place, you just do MLflow run, or invoke it from code. Another key feature for ML projects, it's still the same module, is the reusable workflows, okay? So one customer I met with last week, they have requests coming from an HTTP server, and they want each request to be passed to a trained model to provide a prediction, okay? But they need something to transform the request from whatever the request looks like to what the model expects, okay? Basically extract the features out of the request. And how do you do it? How do you do that? Do you make a Docker container, or do you do it in the application server and then just request what you need? So with MLflow projects, you can basically define a workflow, okay? Do the massaging you need for the data and then pass it. And this gives you two advantages. First of all, you can split your workflows into modular workflows, so you can always take apart and put it back. And you can also interact or work together with your team. So one person is in charge of the transformations, one is in charge of the pipeline, and you package it all together and ship it at once, okay? This is basically how a workflow would look like, okay? Just a few if statements. This is for the sake of simplicity. You can do things that are more complicated than that. Oh, sorry. Okay. Now the last bit, which some of you might have a blind spot for, but it exists, it's real, and it's painful, is how do I pass reliably my models to production? What do I mean by that? I'm a data scientist, okay? And there's the DevOps guy. He knows Linux, he knows Docker, he knows this stuff. I know PyTorch, I know Python, I know Pandas. There's a gap between us, and there's nothing bridging between us. So this is basically the bridge between us, okay? You work with whatever you want, TensorFlow, whatever library you want, whatever tools you want. You then define in a YAML, again, YAML format, how to execute in each library or framework, okay? And as far as the DevOps person or persona, they don't need to know what you're doing, or they don't even care. They can just deploy it. Deployment can be done through REST serving, okay? Can be done to Azure ML, to SageMaker endpoints. If you want to use them, you can use them as functions, UDFs in Spark. It's very easy and comfortable, even if you're not deploying for production and just for your own use. For example, using as UDFs with Spark. This is basically the YAML. So we see that this specific model is comprised of a function of a Python function and a TensorFlow function, okay? This is how we define how to run the TensorFlow bit. This is how we define how to run the Python bit, okay? Or basically how to invoke the TensorFlow from Python, doesn't matter. But specifically, again, the DevOps person doesn't need to go into those details because they are already provided by you, but you do it once and that's it. You can ship to production seamlessly. And the last bit is the model registry, okay? So we all know, we all have files on our desktops which are called model _final, _final, final, really final, and so on. This isn't scalable. This is not how you work when you work under an organization. You're not alone. And there's also, why not, okay? First of all, it doesn't scale. It doesn't scale at the organization. It doesn't scale for you, okay? How do you find the best version of this model, okay? How do you distinct yourself from best version or the best test version or so on files that you kept on your desktop? How did I train the model? Okay, I found the version, but I want to recreate my success. How did I train it? I have no clue because it's just a file or a log file somewhere. How can I track what was provided for each model, and how can I review them? So this is what model registry provide, basically. We register models. Let me just jump ahead because I think we don't have enough time. This is the UI. Everything I'm showing in UI is also exported through APIs. Okay, so this is the UI. This is how you register your model. Okay. Then I have a list of models in my organization, which you can see on the third column, which is in staging, which version is in production. Okay, I can then dive into one of the models. Okay, understand. Look, I can see from which commit in GitHub was it run from. Okay, so I know exactly which version of my code it uses. Okay, I can transition it from staging to production. I can get all kinds of metadata, basically, which is missing today because no one tracks it. Yeah, and this is another view of the same thing. In terms of adoption, I mean, one of the key concerns customers are having with open source projects is what happens if tomorrow nobody works on that, or is it just me using it, or stuff like that. So I want to make you feel very comfortable about the fact that it's widely used, okay? Again, over 50 companies, and we're talking about very big names, which I cannot repeat, but if you go on GitHub and you look at the list of committers, you'll see that very big names are using MLflow. We have, again, 100 contributors, and the most noticeable contribution made recently are database as a storage engine, Docker and Kubernetes execution engines, and an R API, okay? And we also have integrations with all kinds of storage systems and libraries and so on, and the plugin system which allows you to develop your own plugs. We have all kinds of customers and use cases. This is all available online, okay? I'm not gonna tire you with the use cases. You can go online, or you can look, or if you want, you can also talk to me, and I'll provide you some use cases. If you want to experiment with MLflow without starting to your own environment and so on, you can log on to Databricks community, and you can start playing with MLflow, okay, and understanding what it provides before you decide on going to production with Databricks or installing it on your own. And by the way, if you need local references, I can also give you for MLflow. So to conclude, basically, as I said, we at Databricks, we aim to break the barriers between the different silos in the organization, the data engineering, the data science, and the DevOps people, and business for that matter. And we do it in the most open way, okay? All our projects, currently all our projects are open source, so you don't have to commit to us or anything like that. And if you want to learn more, this is the address for the open source MLflow, okay? Or you could just install it on your laptop using pip, and that's it.